Using Wi-Fi with your microcontroller project opens up a vast range of possibilities. You can connect to the internet to send and receive data to web services, and you can create a web-based interface to allow you to use a browser to control and interact with your project. So, let me show you how to set that up. Hi and welcome to Bytes and Bits. There are a number of microcontroller boards these days that come with a built-in Wi-Fi interface, and this lets you connect your project to your local Wi-Fi network, and doing that opens up a wide range of possibilities for extending your project work. So for instance, you can obviously use your Wi-Fi network to connect to the wider internet, and that will allow your project to both gather data and push data up to various web services and websites, or you can use other devices on your network to communicate with and control your microcontroller project. So in this tutorial, I'm going to take you through the basics of using a Micropython based microcontroller. So we're going to use the Raspberry Pi Pico W in this tutorial. But again, it would work with any other Wi-Fi enabled device that's capable of running Micropython, such as your ESP32 and various Arduino boards and so on. And I'm going to talk you through and show you how to connect to your Wi-Fi network, or how to use your Pi Pico to generate its own independent Wi-Fi network, and then how we can then use that to talk to devices on the internet, and also then how we can set up a web interface so that we can actually use a mobile phone or laptop to connect to the Pi Pico using a web page that the Pi Pico generates, and then use that to both communicate with and control our little microcontroller projects. Now, to say, this is going to be the initial basic setup. I will do a second tutorial which covers in more depth how we can create a more robust web, well, it's going to be a REST-based web API for your Pi Pico, which makes it a much more powerful system. But in this one here, we're just going to get this general setup ready and then show you how you can do some basic control of your project. Now this video is the full version, and it is a good sort of 45 to 50 minutes long. I will produce a second sort of summary version which will just get straight to the point of what code you need to run. But if you do want to understand exactly how everything is working, then please do stick with this version, as I'll take you through everything in quite fine detail. So, first thing to do then is let's get our Raspberry Pi Pico connected up, and we'll get started. So just before we get to the actual code, just to make sure that everybody's in the correct place, you will of course need to have your Python development system set up and Micropython installed on your microcontroller. So if you haven't already done that, please do have a look at my previous tutorial video which shows you how to set all of that up. And I'll put links to that in the description down below. Now, I'll also be going through quite a bit of code and different files in this tutorial. So I'll put all of that into a GitHub repository. And again, I'll put links to that in the description down below so that you can download the whole package and get started on that code. So let's have a look at the actual software we need to get this interface working. So for our Pi Pico to communicate over Wi-Fi, we first of all need to connect to a Wi-Fi network. And that's what this block of code here is going to show you how it works. And the important bit here is that we are importing this network library, and that is the one that contains all of the further classes and so on that allow us to control and work with the network interface chip. So in this block of code then, we are going to connect up to my home Wi-Fi network, and for that we need to have the network ID. So this is this SSID, and that is the broadcast name that your Wi-Fi network uses. We'll of course then need the password, And all I've done here is I have just buried my actual values inside a little class called network credentials, and that's just really so that I don't have to keep blanking them out on this video. But really all you need to do here is just put a string in here with whatever it is, so whatever happens to be your Wi-Fi connection. So to make this all work then, we are going to use this, as I said, this network library. And the first thing we need to, let me just get rid of that stuff. And the first thing we need to do is to tell it what type of connection we want to make. So there are really two ways in which you can connect up the Wi-Fi on the Raspberry Pi Pico. So we can either use what's known as a station interface, and that's where the Pico becomes just a device on your home Wi-Fi network. So it's going to connect itself to any existing network that it has that is in range for it. We'll see a bit later on using an access point interface, and that's where the Pi Pico can actually generate its own Wi-Fi network, and we can then connect devices into the Raspberry Pi Pico. But say we'll do that a little bit later on. So once we have told it what way we want to connect, we then just need to turn on the actual Wi-Fi interface, and that's what this active method here is doing. So once we've then turned on the interface, we want to ask it then to connect to our Wi-Fi network, and that's all we're doing here. So again, we're using this wireless LAN object that we have returned back from this method call. So it returns us back this object. We then call the connect method on that, give it our network ID and our password, and it should then try to negotiate a connection with our Wi-Fi router. And that's all that's happening then in this while loop. So it's going to take a bit of time for that negotiation to take place, and we just want to wait in this loop until that either succeeds or fails. So I'm just using a little loop here which is going to wait for a maximum of 10 seconds, and it's going to check, each time it checks it's going to take a little sleep after that, so we're going to do a check every 1 second. And the check we're making then is looking at this wireless LAN status. And that will return us back what our current connection, what the progress of it is. So initially we will be in the idle status, which is value 0. Once we initiate our connect method, it will go into this status connecting. Then at some point it will either manage to negotiate a connection or the connection will fail. And we can see here then we then have a number of failed statuses depending on what has happened. So again, if we get our password wrong, we'll get a -3 coming back. Or if we get a successful connection, then our status will move to 3. And that's what this line of code here is doing, is just checking for either an error or a success. So if once we get that, we can then break out of this loop, and we can then check and see what actually happened. So we're checking here then first of all for an error, and if we get an error then we will just come back and our code will end, and it will just say that we had a connection failed. You can of course, as you've seen here, we can actually look at what the error was, and we could, if we want at this point here, notify the user and perhaps go back and retry or something. But for the moment we're just going to simply, if it goes wrong, we're just going to close the code down. But if we get a successful connection then, we're going to print that out. We can then gather some information about our connection. So this method here, this ifconfig, will tell us how our Wi-Fi connection has been set up, and that returns back a list of 4 values. So the first value on our list is the IP address. So this is the IP address on the Wi-Fi, on our local Wi-Fi network that the Raspberry Pi Pico has connected to. It then gives us our network subnet mask, our gateway, and our DNS server. So again, the gateway is in effect our router's address, and the DNS server is where our Pi Pico is going to ask for DNS information, and that usually defaults back to your gateway, and the Pi Pico will simply ask your gateway where websites exist on the internet. So that should hopefully then let us make a connection. So let's put that onto the Pico and see what happens. So I've uploaded that onto my Raspberry Pi Pico as a file named connect.py. So to get that to run, I just simply need to import my connect code, and that should then run. And we can see here it's now trying to connect to my Wi-Fi network. And then once it makes that connection, we can see there it's been successful. So my Pi Pico has connected itself to my Wi-Fi network, and it's given, and my router has assigned it this IP address. So that will come in handy later on when we want to talk to my Raspberry Pi Pico. We've now got my subnet mask. So in my router, it's only this last block of numbers which changes when we have different devices connecting there. And of course, that's the address then of my Wi-Fi router itself. So we've got a successful connection, and my Pi Pico is now able to use this Wi-Fi connection to do, well, whatever you would want to do with a Wi-Fi connection. So let's see if we can access some web-based service and pull down some information from that. So at the moment, our Raspberry Pi Pico isn't aware of what time and date we have. So let's give it that information. So there's a service here we can use, this timeapi.io, which offers a free time zone web service. So if we click on the Get Started here, we can see that there are a number of API calls that we can make here. And basically what's going to happen is that our Raspberry Pi Pico is going to send a request to this website. And then this website is going to send back a block of data, which then we can decode and then gather the information from. So these APIs then use these things called GET calls, and this is how devices communicate over the internet. So it's going to make an HTTP GET request to this particular web address. So we're going to be calling this timeapi.io/API/time/current/zone. We're probably going to specify some information after that, and then this will then come back and respond with us. Rather than responding back with a web page, it will respond back with some data. So let's have a look at this particular request then. So we can see here that there's a number of things we need to fill in for this. So let's try this out. And I'm based actually then in the UK. So I'm going to use a time zone called Europe London. And if we execute that, we can see how it works and what information we're going to get back. So what this is really telling us then is that to use this API, we need to send a GET request. So this thing called curl is one of the standard pieces of software you can use to mimic these requests. And that's just the code which is used to set up that curl request. But of interest to us then is the actual request URL that we need to talk to. So this is where we are going to send a GET request to this web address, and you can see there that this first block there is that API. We call them API endpoints. So that it gives us access into a particular place within the code in this website. We then use this thing called a query string. So at the end of your web address or your URL, you sometimes, and you'll see this as you browse through the internet, you'll find a little question mark, and then after that there are a series of variable definitions. So here we're saying that's our URL endpoint. We then want to send some data in our query string. So we're sending across a variable called time zone, and we're setting that equal to this Europe London value. So when we send that GET request across, this website is going to respond back with some information, and this is what it's going to send back to us. And this is in one of the standard formats for data transfer over the web, and this is known as JSON. So it's JavaScript notation or JavaScript object notation, and it's a very cross-system friendly way, and also for human friendly. We can actually see exactly what the data being sent back is. So it's going to send us back an object which is denoted by these two braces. And inside that object there's going to be a number of parameters which define various pieces of data, and you can see very much here. So it's sending us year, the month, day, and so on. And we will be able to then take hold of this information back on our Pico, decode it, and pull out the information we want. So let's go and have a look at how we actually do that then on the Pi Pico. So I have a new file called getTime here. All of the code I'm using in this tutorial, I'll be putting all of that into a GitHub repository, which I'll put online for you all to download. And that will be, the links for that then will be in the description down below, or if you go off to the project page for this tutorial, you'll find all the information there as well. But it's basically the same code that we had in the previous connection file. All I've done here is we're using an extra library, which is this the requests library, or the Micropython version of it. And that then will provide us with a mechanism to generate these HTTP requests. So as you can see, all the rest of this is all the same as it was before. But down the bottom here, we then have a forever loop, which is simply going to make these requests. So you can see here we're using this uRequests library. It has a get request method, and for that we just simply need to then supply it with the URL for our API call. So you can see here this is exactly what we had on that on the website's test system. So we have our endpoint query string, and then we're supplying it with the time zone that we want. Now I just put a little bit of code around this, so we're in this line and this line here, we're just timing how long this get request takes, just so we can have a view on the performance of the Pi Pico over the internet. The requests.get method then is going to come back to us with the response from the web server. Now that response has got a range of data embedded into it, but we then are able to use a few of the inbuilt methods in the response object to get that data out. So there is a JSON decode method which we can use there, and that will generate a dictionary in effect, and we can then pull out the date time value from that returned object, and that's what we're going to print out. So we should be able to see the time, or the date time value, that comes back from this web service. And then we're going to do a sleep for 5 seconds, then just repeat that. So every 5 seconds we should be querying that API and getting back a date time string value. So let's have a look at that actually in action. So again, for this we just simply need to import our file, and that should kick off that piece of code. So getting a connection, once we've got our connection, then it should start sending those get requests and start bringing back the time. So you can see here that we actually have the response back from that web API. But the important thing here is that if we look at this, it's taking us around about 2.5 seconds to actually complete that get request. So from when the request is generated to when we actually get a response back and are able to print that out. So that is something that we do have to consider. If I just jump us back into the code for a second. So again, you can see that that is then just doing every 5 seconds, it's going off, and we can see here that we are getting our latest timestamp coming back. But let's just jump back into the code and see what the significance of this value here is for us. So back at our code, we can see here that the actual communications with the web API take place at this line of code. So we mark the start time and then we print out the end time in that third line. But our code in effect is stuck on this particular line for that 2.5 seconds, and nothing else is happening on the Pi Pico, and that is something you do need to consider when you're using this web system, that the basic software and the basic interface and controls for accessing the web interface use what's known as blocking code. So certain methods that you're calling take over the Pi Pico and block any of your other code from running until they have finished. Now there are a number of ways around this, which I'll actually be covering that in a second follow-up tutorial to this one. So this tutorial I'm really going to concentrate on the basics of getting everything up and running. And as you're seeing here, if waiting for that response isn't such an issue for us as it is here, then everything is fine. But if you are thinking that perhaps you have this request in the middle of some sort of control loop, where you are controlling some sort of motor or whatever, then obviously having a 2.5 second gap in your processing could make things very, very difficult for you. So do be aware of how this works and its limitations. But for now then, in simple terms of getting hold of some data from a web API, you can now see the basic process. So again, we have this GET request, we can send that off, and this GET request then is a proper HTTP GET request. So you can access, in this case here, we are accessing an API, which we know is going to send back some JSON data. You could use this to actually request web pages and then scrape those web pages for certain data within them, and so on. But basically, this is going to send you back whatever this particular URL, whatever data that sends back, whether it's, as I say, JSON data or just some HTML text, that will come back as a string value in effect. There are other methods built into the response you get back which will allow you to deal with that. And again, do have a look at the documentation to get more details on that. But as I've seen here, a lot of the time you'll be using these GET requests then to access APIs, and mostly they will come back either as JSON. Some of them will send just back some plain text answers, but a lot of them will come back as JSON structured data, and this is how you then can decode that and pull particular data values out of that returned data. So just to recap then, we've so far got our Raspberry Pi Pico connected up to our home Wi-Fi connection, and that allows us to send HTTP requests out to other servers or API systems to gather information. But we now want to look at how we can use a device to connect to our Raspberry Pi and then communicate directly with the code running in our project. So if we consider any device that we connect to our router, and whether that's over Wi-Fi or over Ethernet, our router builds up this internal network where every device is allocated an IP address, and that is its specific address within our internal network. And we can actually use these IP addresses then to start communicating between devices. So just as we saw in the previous example where we sent an HTTP GET request out to some external server, we can actually use a device such as our mobile phone to send a GET request to our Raspberry Pi Pico at its internal network IP address. Now once we send that GET request, our Pi Pico, all we have to do is to make it able to collect that request, decode it, handle it, and then send back some information if required. So in effect, what we're actually doing is turning our Raspberry Pi Pico into a web server. So let's have a look at how we code that. So we're going to work towards building up a little project where we can use a web page interface to allow us to use a mobile phone or something to control an LED on our Pi Pico. But first of all, we need to be able to receive these GET requests coming from different devices on our home network. So we're going to modify the code we already have developed. We need one more library, one more package, which is the socket library. And we'll see where that comes in just a second. So I've added that import at the top of our code here. Again, I will be using this pin definition to control the pins a bit later on. But let's work just first on this side of the sockets. So we go through our normal idea where we are connecting up to our router. But the first thing we need to do here now is we need to open up a socket. And what a socket basically does, it allows us to open up a doorway onto the network for our Pi Pico and then connect that doorway to some sort of data stream. And that's what's happening in this block of code here. So there are a couple of ways of setting up our socket. You'll see in quite a lot of examples it uses this notation here, which is slightly more complex, but it is a slightly more powerful way of setting up a socket. But for now, we'll just do it the simple way, where we're going to say, I'm going to create this socket address by giving it an IP address, and again we're gathering that IP address up here from our Wi-Fi configurations. Remember, whenever we do our Wi-Fi, we can call this function ifconfig, which sends us back 4 numbers. The first of those numbers then is the actual IP address that's been allocated to us by our router. So we're saying here, I want my socket address to be at my IP address, and I'm going to open up port 80. Now port 80 is the default HTTP address. So whenever you contact a website using HTTP, not HTTPS, that works on a different port, but HTTP requests come across on port 80. So in effect, doorway number 80, we're going to open that up, and we're then going to connect that to our socket. So this is where we are now creating a socket, and we are then binding this socket to this address, so that at that point there we now have a socket which is connected to port 80 on our Pico's Wi-Fi interface, and we're then going to start listening to what's coming in on that port. Now the number inside this listen method call tells us how many requests we can queue. So in effect, we're going to have the requests we're dealing with and one queuing in behind that. And that's before, if everything else comes in, if we start hitting it with lots more requests, the Raspberry Pi Pico is just basically going to say that it's not able to deal with things, and you'll get an error message coming up on your web browser. So at this point then, we can see here that we're just going to get it to print out telling us that it is now listening to this particular IP address. So this bit here is starting to set up the control of our LED, but for now we're not going to just work with that. We're just going to try and make sure that we can actually get some request data coming through from our mobile phone. So we're going to do a forever loop here. And we're basically going to say that we want to set up a client and capture the address of the client. So this is going to be our mobile phone, which is connected up to our same Wi-Fi connection or our same home network connection. So we're going to say we want our socket, so remember S is our socket that we bound to this port 80. We want that to accept a connection. And that connection, of course, then will come from our client. So our code is going to sit here waiting for somebody to connect to us. What we're then going to do is we're going to, from our client, we're going to receive some data. And I'm telling it here to receive up to 1K of data coming in. So our client will be sending in a GET request. We will receive a block of data from there, and then we're just simply going to print it out just so we can see exactly what has been sent across our Wi-Fi connection. We're then going to send a message back to the client, so we're going to send something back and just tell it that we have received the message, and we're then going to close our connection just to clean things up. If you don't close it, it will be collected in the garbage collection as the Raspberry Pi Pico's Micropython system runs through, but it is just a good idea just to close it now, just to release those resources. So onto our Raspberry Pi, and I'm going to import my simple LED code, run that. So again, it's connecting up to my Wi-Fi, and it's now turned on our Wi-Fi, and we can see it's now listening on that port 80 for some sort of connection. So let's grab hold of this IP address, and let's come across, open up a browser window, and I'm just simply going to browse to that IP address and see what happens. So there we go. We've now, on our browser then, you can see that message received has come back. But if we look at what's actually happened on the Pi Pico, we can see that we've got this whole block of data coming up. And what's really happened here is we actually have two GET requests. So we can see here the string that is printed out, the B here means that it is a byte string. So each of these characters is actually being represented by a single byte. So it is still a string, but it's just this special byte version of a string. And we'll deal with that a little bit later on. But you can see here we have one GET request sitting there and a second GET request sitting there. Now, this lets us see the structure of a GET request, and this is what we're going to have to deal with to be able to decode what's happening inside our code. So this first, well, let's take the second GET request here. So we can see here that we have a GET request. So we've got our GET method there. So this is called a method or the HTTP verb. That is then followed by the resource that we are trying to access, okay, or the actual URL within our website. And then we have our protocol that's being used. The /r/n is in effect a new line character. So this piece of code here is actually the first line of our HTTP request. And as I said, it's saying I want to get hold of the favicon.ico resource, and I'm using HTTP version 1.1 protocol. You can see that the same is happening up on this first request here, where we are saying it's a GET request. We are accessing /, which is the basic root of our website. So we haven't specified a resource. It will return back the default page, and we're using HTTP 1.1. So that's the actual request that we sent from our browser. So the reason I talked to this one here first is you can actually see what resource it was accessing. But this means that we were accessing just the default page, and that was when we used up here, and we just used that default IP address, and that will access the default web page. When we access a website, our browser will always check to see if there's this favicon.ico, and that's the little picture you get up here whenever you access a website. So because we haven't sent one back, it just does this default web address thing here. But in effect then, this block here, this is the GET request that we now have to start working with and decoding. And you can see there's lots of information embedded within that. But for the moment, we're just going to concentrate on this very first line. And that will let us do quite a bit of decoding and control within our project, where if we can access different URLs within our web pages, then we can use those different URLs to perform different actions in our code. So let's look at how we can actually decipher that then and start allowing us to control an LED just using a web page interface. So we first need to decide what URLs we're going to expose to the user. So we already know that to call up the initial web page, we're simply going to send a GET request to the IP address, and that's going to then trigger this / default page request. And for that, we're then just going to have to send back the actual HTML that builds up the web interface itself. We'll then want to have two further URLs. One of those is going to allow us to turn the LED on, and one of those is going to allow us to turn the LED off. So basically, we'll create these URLs. Our IP address /LED on and /LED off. So if we want to turn the LED on, we're simply going to have to get our browser on our mobile phone or whatever else we're browsing with to send a GET request to that URL. So let's start by having a look at the HTML code that we're going to need for our web page. And remember, this is what the user is going to see when they log on to our Raspberry Pi, and this will have the controls then to control that LED. I'm not going to go deep into how HTML pages are built up, but just enough to just cover what we need. So some of this code is sort of boilerplate that you need to have. So you need to have your doc type declaration. We then have our HTML tags which hold all of the HTML. We then have a header section inside which we can put in a title, and that is the piece of text that comes up in your browser tab at the top of your window. We then come into the actual body of the page itself. So this is what you're actually going to see in the browser window. And what we're going to do is we're going to put a paragraph in. So HTML is built up of these tags, so start tag and an end tag, which has that little slash there. So that's a paragraph of text which just says to click the buttons. We're then going to create an actual button itself. So this tag here, so input type equals button, creates an actual clickable button. We're then going to say what's going to happen when we click that button, and this is a little JavaScript piece of code here. So when we click the button, we're going to in effect send the browser to a new URL, and this is where we're using these two URLs, so these endpoints in our API system in effect. So our Raspberry Pi Pico will be able to respond to this /LED on and the /LED off GET requests, and that's what will actually control then the LED turning on and off. So we're going to need to work out how, when we get these requests, we can decode that URL, work out which one the person has been requesting, and then take the appropriate action. We're then going to put a new line in there, just a bit of a space, just to space out the buttons and so on. And then we're going to have this piece of text here. And what I'm going to do here is our Pi Pico, once it receives an on or an off request, it's then going to notify back. So it's going to send this web page back to the browser, and it's going to replace this little token. So I use this for a little token, so asterisk asterisk, then a token name asterisk asterisk, and we're going to use the Python string manipulation, the string replace function. It will look for this token, and then we're going to insert either in there an on or an off, depending on whether we've just turned the LED on or off. And that will then appear, of course, in the user's browser and will give a bit of feedback. So they'll effectively open up their web browser, they will see two buttons, they can click the buttons to turn the LED on or off, and the system will just report back what the current state is. So we next need to have a look at how we can actually decode which of these URLs the person has requested. So before we look at decoding those GET requests, I'll just first take you through how I prefer to put my HTML code into my applications. So I've created an actual HTML file on this side here, which has got the code that we've just been looking at. The reason I do it as a file is that by making an actual HTML file, I can actually view this in my browser and check what it looks like before I start embedding it into my Micropython application. To actually use that then, if we come across into this, so this is the actual code which runs on the Pi Pico itself over on this side. You can see that we are pulling that information in as a file here. So I'm opening up a file handle connected to that HTML file. I'm then reading in the contents of that file into a variable called HTML. And I'm then closing my file at that point there just to release any resources. So at this point, my variable HTML contains that HTML file. I can then take my token that I said there. At this point here, I'm working out whether my LED is on or off, and I'm tracking that using this LED state variable. So whenever we turn the LED on, we're going to set that to true. When we turn the LED off, we're going to set it to false. And you can see here, all we're doing is working out whether we need to say off or on. And I'm then just simply replacing that token with my LED state. And then we send that back to the browser using the client connection, and then close all that down. So at this point, we will come in. We're going to be deciphering here whether we want to turn the LED on or off or just display the page. We then generate our HTML, send it back to the client, and then the client can then see that together with buttons and so on. So let's go off now and see how we're actually going to decode that URL coming in. So back to our Pi Pico Micropython code then, and we'll see how we decode this. So we've already seen that we are receiving the actual get request information in this variable raw request, and we're doing that then, of course, we're receiving the bytes coming in. Now, as we've already seen, that is coming in as a byte string, which is still a string, but it does behave slightly differently in certain circumstances. So we first need to translate that into a normal string. And we're doing that using this decode method here. So we're taking our byte array and we're decoding it. The byte array, because it's an HTTP request, it's usually going to be in UTF-8 format. So we're just specifying that there. And at this point, we should now have our raw request variable as a normal string. And we'll print that out. So the next time we run this bit of code, we should see it now behaving as a normal string. So once we've got that, we can start to break it apart and pull out the bits that we need. So if we split our string on the spaces, so to actually split it up into words. The two words that we actually need then are the very first word, so the very first word of the first line. As we've seen, that always specifies our HTTP method, and for us that will normally be get. The second word will actually be the request URL, which is the one that we're using to specify whether we're going to be turning an LED on or off. So if we pull those two parts out, we can then use a bit of an if statement then to test that. So I'm using this find method to look for that string inside our URL. Again, sometimes for whatever reason, there may be bits coming in after that. So if there happens to be any query details attached at the end of that with a question mark, or maybe a bookmark with a hash mark or something like that. So there are certain circumstances where we will get more than the bit of string that we want. So if we do an equals test on that, we might find although somebody has requested the LED on URL, it doesn't match. So I'm just saying on this line is if it does contain this piece of text, then we'll just assume that that is the LED on URL being requested, and we will do the appropriate action here by setting the LED state and turning it on. And similarly then for the LED off URL. If it is neither of these URLs, then we're just simply going to let the system just pass through by doing nothing to the LEDs, and it will just then, of course, send out the HTML as it is. We could do a lot more testing in here to specifically test for unknown URLs and so on, but for the moment we're just going to assume that if it isn't on or off, then we'll just assume we just send back the page. And we've already seen then that the rest of that code just simply sets up the HTML, puts in the correct values, and sends that back to the client. So let's have a look and see if that actually works. So let's import our code again and see if that all works. So we've got our connection, we've got our browser up and running here. Let me just refresh that just to make sure we've got it all set up. So there we have our, you can now see that our get request is being decoded as a proper string. So we're getting all the new lines coming in here, and you can see each of those individual parts of our get request. So let's try sending it some of the buttons in. So if I press the LED on button, you can see there we have our get request to the LED on, and it should come on here. And if we have a look actually on our circuit board, you'll see that our LED is on, and it's the little red LED. That circuit board that I've got there at the moment, I've been working on the next tutorial after this one, where we're going to be looking at a full web API running on the Raspberry Pi Pico, rather than this. This is a fairly basic system we have at the moment using these URLs. The next lesson will go much deeper into providing a proper web-based API for your project. So let's just concentrate on that red LED. So that turns it on. If I hit the next button, then of course we can see all of our requests coming up here. Again, our LED off request there, and the LED has obviously gone off as well. So there we have now being able to control our Pi Pico project by putting up a web interface, allowing various control buttons and so on, and feedback coming back from our Pi Pico, and we now are able to control our projects and talk to them over our Wi-Fi connection. So the last thing I want to cover in this tutorial then is, what if we don't actually have a Wi-Fi network that we can connect into? Well, at the very start of this, we did talk about, when we set up our wireless connection, that when we turn the interface on, we have a choice of 2 modes in which we can set it up. So we've been using the station mode, where the Pico accesses an existing Wi-Fi network, and that lets us then of course use that Wi-Fi network to get out onto the internet. But we can get the Pi Pico to generate its own Wi-Fi network, and this is the access point interface. So let's go through and see how that comes on. So I've just really modified that LED code, and we're just doing it now through its own access point interface. So for the access point, of course, we're not going to be connecting up to an external Wi-Fi network. So we can now set up our own SSID and password, and that's what we're setting up here. So it's going to broadcast itself as the Pi Pico access point, and the network password is just going to be password to get onto this. So when we specify our wireless network, you can see here that we're using this AP_IF constant, and that will tell the interface that it wants to generate its own Wi-Fi network. So we then are configuring that network, and we're setting up the SSID and the password. And then we're turning on the Wi-Fi network itself. So at that point, the Pi Pico will generate its own Wi-Fi network and then start listening out for clients that are trying to connect to that. So in this little bit here, so once we've turned it on, we simply have to wait for all of that to become active. And you can see here, we're just waiting for the active flag to become true. And if it's not true, we're just going to say waiting, and we'll just do a little sleep while we sit in that loop waiting for it all to become active. So in this particular bit of code, of course, as soon as we become active, we are getting it to tell us how it set itself up and what IP address it's working on. This IP address will be fairly constant each time that you enable this interface. So once you find out what it is, it will really be set at that each time you turn it on. Now after that, we now have our Wi-Fi network set up. Our Pi Pico is attached to that, and all the rest of the code is exactly the same. So you can see here, we are simply picking out the IP address of the Pi Pico. We are then binding a socket to that in exactly the same way as before on port 80, and then everything else is exactly as it was before. So let's power that up and see if we can get that to work with my mobile phone. So if we now start up that simple LED access point code, we set it boots up, and it pretty much instantly turns on the Wi-Fi. It doesn't have to bother connecting to anything. So it set itself up as our Pi Pico AP access point. It's given itself a web address or an IP address there of 192.168.4.1, and that's what it will be listening to on port 80. I've now got my phone screen sitting here, which you can see, and I don't know if you noticed, but it just popped up there once we set that code running, our Pi Pico access point as an available Wi-Fi connection. So if I connect into that, and there we have ourselves connected. Again, it's saying there's no internet, and of course that's because our Pi Pico now has no internet connection. We're running just a local network. And again, my phone's complaining about that, but no, we want to stick with our Pi Pico app. But let's go back to our web browser. You can see that there are certain, my phone itself is trying to work out if it can access the internet through this, which is what these little GET requests are happening here. But that web address then, if I use that in here, so if I try and type that in, so 192.168. 4.1, so that one there. So if I click onto that, and let me just adjust my screen so we can actually sort of see that on there. Okay. So again, we've got our web request coming through. So you can see here that we've got our GET request coming through. It's looking for the default page, and of course we've just served it back then the actual web page itself. Our LED is off. So if I now click on here, again it's working in exactly the same way as it did in our last system. Again, each time of course it goes back and refreshes back to that smaller screen, but you can just about see the two buttons on there, and I can now of course control my LED from these two buttons. But this now gives us a totally standalone Wi-Fi connection. We're not reliant on any existing Wi-Fi system being in the area. So we could, if we wanted to, if this was out in the middle of nowhere, we could have our Pi Pico generating its own Wi-Fi network. We could walk up with our handset, log on to our system, and then start controlling our project over a Wi-Fi link. So that should cover everything you need to Wi-Fi enable your Micropython projects. As I said at the beginning, this is very much a basic web interface. I will cover a more in-depth REST API version in the next tutorial. So please do make sure that you subscribe to my channel to make sure you don't miss the notifications as to when I release that next video. So I hope you've enjoyed this tutorial. I look forward to seeing you again sometime very soon. So bye for now.
For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.